In the last level, we looked at two favorable outcomes, but only one attempt. And now we're going to talk about compound probability, which is two favorable outcomes, but with two attempts. So in other words, both of them have to happen. And the two words we're going to talk about besides independent and dependent are and or. Now remember, when we did the dartboard, we had favorable outcomes whether we would hit 7 or 13. And either one would make us a winner. But in this case, think of it as you would have to throw 2 darts. So the first time you threw, you would have to hit 7. And then the second time you threw, you would have to hit 13. So both of them would have to happen for you to become a winner. And that's harder, isn't it? So let's take a look at how we figure these out. But first, let's look at the difference between independent and dependent. Okay, so two events are independent if the outcome of the first event doesn't affect the outcome. Okay, so doesn't affect the outcome of the second event. Imagine the bag of marbles that we always use in these problems. Okay, let's say there's 20 marbles and there's 5 green, 5 red, 5 yellow, 5 blue. Okay, so the chances of getting a blue one would be 5 out of 20, or 1 out of 4. And then after you pick it, you put the marble back, so the second time you're still picking from 20 marbles and there's still 5 blue. So the second time, the probability of getting the blue marble would be exactly the same as it was the first time. So once you put the item back, it did not affect the probability of the second attempt, okay? But if two events are dependent, the outcome of the first event does affect the outcome of the second event. Let's think about that same bag of marbles again, okay? Remember, we picked the blue one the first time, but this time we don't put it back. So the second time you pick, there's only 19 marbles left in the bag, and remember, you did get the blue one, so now there's only 4 blue. So the second time, your probability would be 4 out of 19, and the first time it was 5 out of 20. See the difference? Because you didn't put the marble back, it affected both of these. Okay? So let's take a look at a couple of these examples and see if they're dependent or independent. Okay? So I'll do the first one with you, and then you can do them on your own. And I'll tell you what they are. Okay? Mason and Jacob get massages from the same person. On Monday, Mason calls and picks one of the available appointment times. On Tuesday, Jacob calls and picks one of the remaining appointments. Are the two events dependent or independent? Well, what do you think? They're dependent because when Mason called the first time, he took one of the available spots, and Jacob called the next day and there were only some of the ones left. Those are the remaining ones because Mason got the one he wanted. So that is okay. Example 2, student at Rossview Middle is picking out a song to download. At the same time, a teacher at the high school also happens to be deciding on a song to download. These are independent. One doesn't affect the other one at all. Okay, just because the student picks a song to download doesn't mean that song won't be there for the teacher to download. So that is completely independent. Example 3. Go ahead. What do you think? Take a second. Okay, what do you think? These are independent because he did put it back. And that's important because when he puts it back, there's the same number of all the marbles as when you picked the first one. So this is independent. And example 4, this one is not put back. So what do you think? This is dependent. Okay, remember, without putting it back, the second time you pick, there are less marbles and less of whatever color you actually chose. Okay, so how do you figure this probability? Well, pretty simple. You take the probability of the first event and you multiply it by the probability of the second event, and that's all there is to it. Okay, so take a look at example 5. You pick a card at random, put it back, and then pick another card at random. Well, this is independent because we did put it back, so each time there's 4 cards to pick from. So what is the probability of picking a number greater than 1 and then picking a number greater than 3? Okay, so the probability of the first event, how many total outcomes are there? There's 4. And how many are greater than 1? 3 of them. We put the card back, so the second time there's also 4 total possible outcomes. And the second event is greater than 3. Well, there's only 1 card greater than 3. So the probability of getting the 4 is 1 out of 4. How do you figure the probability of both things happening? It's the first probability multiplied by the second probability. So it would be 3/16. Okay, go ahead and take a look at this one. Now look, this time we're not putting the card back, right? This is a dependent event. So remember, the second time we pick, there's only going to be 3 cards to pick from. Okay, so what's the probability of picking a 4 and then picking a 5? Okay, well the probability of getting a 4 is 1 out of 4, and then picking a 5. Now remember, we didn't put it back, so the second time there's only 3 cards to pick from. And there's only 1 5, so the second time we have a 1 in 3 chance of getting the 5. So how do you figure the compound probability? 1 in 4 times 1 out of 3. So that would be 1 out of 12. Okay, and before you go, a couple things I want to show you definition-wise. Think of all the possible outcomes you could have if you pick 2 cards and put 1 back after the first pick. You could get a 4, 4, 4, 5, 4, 6, 4, 7, 5, 5, 5, 6, 5, 7, 6, 6, 6, 7, and a 7, 7. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The total number of possible outcomes is called a sample space. And the other thing I want you to be aware of is, let's take a look at our compound event again, where it says, what's the probability of picking a 4 and then picking a 5? Remember, if you don't pick a 4 the first time, you can't then try to pick the 5. You have to get the 4 first and then the 5, otherwise you would not satisfy this probability. So just something to keep in mind if you were actually in a contest, or if you're designing your game, which you're going to get to in a second. Remember, the person can't win at this level unless they get that 4 first. Once they get the 4, then if they want to try again, they have to get the 5. And that's how that works. Okay, good luck with your game. I'll be talking to you in a little second about how to do that.